Hello guys, welcome back to this concept based YouTube channel. Today we will discuss class 9 maths problem based on exercise 2.1, which is a chapter of polynomial. As we can see here, we are given with this question, that is to write the coefficients of x squared in each of the following given Roman numbers. At first, we can see that in Roman number 1 we are given with 2 plus x squared plus x, and in Roman number 2 we are given with 2 minus x squared plus x cubed. In Roman number 3, it is pi by 2 x squared plus x. In Roman number 4, we are given with root 2x minus 1. And in Roman number 5, we are given with 2x minus root 2x minus 3, x squared minus 3x plus 1. All these Roman number 5 are the questions that is given to us. So in order to clear our doubt, or in order to solve the problem, let us proceed to the first Roman number. In the first Roman number, we are given with 2 plus x squared plus x. Actually, as the question has given us, or the question has asked us to find coefficients of x squared. And the first question, or in the first Roman number, as we can see, the polynomial has x squared plus x plus 2. So among this, we have to check it, is there any coefficients of x squared? Okay, let us write solution. Here it will be coefficients of, actually the question has access to write coefficients of x squared. Coefficients of x squared, actually here we have x squared. If there is no number that is written just before this x squared, then we have to write it 1. That means coefficients of x squared should be 1. If it talks about coefficients of x squared, then we have to take it whatever number that is just before this x squared. Okay, so that will be called as coefficients of x squared. According to that, in the first Roman number, coefficients of x squared will be 1. Okay, if here the sign is plus, then no need to write it. If here the sign is minus, then we have to write minus here. Okay, so that's it for the first Roman number. Then let us proceed to Roman number 2. In Roman number 2, we can see that 2 minus x squared plus x cubed. Actually, the question has asked us to find coefficients of x squared. Here we have to write it, coefficients of x squared. Coefficients of x squared is, what is the number that we have just before this x squared? That is minus 1. If there is no number, as we already talked about this, if there is no number here, it will be 1. Here the sign that we have is minus, that means coefficients of x squared will be minus 1. Is it alright to all of you? Okay, then let us move to Roman number 3. In Roman number 3, we are given with pi by 2 x squared plus x. The question has asked us to find coefficients of x squared. Now let us write coefficients of x squared. Coefficients of x squared. What is coefficients of x squared? As we already discussed, what is coefficients of x squared in earlier classes? If it talks about coefficients of x squared, whatever number that we have just before this x squared, we have to take it. Here, just before x squared, we have pi by 2. That means the coefficients of x squared in this polynomial will be pi by 2. Can you understand it? Then let us proceed to Roman number 4. As we can see here, in Roman number 4 we have root 2x minus 1. Actually, according to the question, we're gonna find coefficients of x squared. Here we don't have any x squared. That means the coefficients of x squared in this polynomial should be 0. Okay, coefficients of x squared is 0. Now let us proceed to this Roman number 5. The question that is given to us, it is in the form of like this. We have to simplify this one in simplest form. In order to do that, first let us write the same question in solution. X squared minus 3x plus 1. By using some identities, we have to multiply these two. First it will be 2x into x squared minus 3x plus 1. What is the sign that we have here? That is minus. And let us write minus here. It will be 3. Here it will be x squared minus 3x plus 1. Okay. Then 2x times x squared will give you 2x cubed. Minus 2 times 3 will give you 6. X into x will give you x squared. Plus into plus will give you plus. 2 times 1 that will give you 2. And x. 2x times 1 that will give you 2x. 3 times x squared that will give you 3x squared. Minus into minus that will give you plus. 3 into 3 that will give you 9. It will be 9x. Minus plus that will give you minus. 3 times 1 that will give you 3. Okay. Is it clear to all of you? Okay, then let us proceed it. Here it is 2x cubed. So is there any other 2x cubed? That is just same with this number. If there is some number that is same with this, then we have to bring it in that side in order to add it. Then let us write, if there is no number, then just write this one. Then what is the other number that is just lower than this degree? That is 6x squared. And is there any other x squared? That is minus 3x squared. Now let us bring this minus 3x squared here. Plus 2x plus 9x minus 3. It will be 2x cubed minus will give you plus. And what is the sign just before the greater number? That is minus. We have to use the sign that we got it after we multiply this minus as well as this. That is plus. 6 plus 3 is 9. And we have to take it the sign which is just before the greater number. That is minus. What is this? That is x squared. Then plus into plus will give you plus. Okay. 2x plus 9. 2x plus 9. That is 2x plus 9x that will give you 11x minus 3. Now actually the question has asked us to find coefficients of x squared. Here what is the coefficients of x squared? Actually minus 9 is the number that is just before this x squared. That means the coefficients of x squared that we're gonna take in this polynomial is minus 9. Okay. Coefficients of x squared is minus 9. Okay, that's all for this. And if you have any kind of doubt related to this, then you can ask me even in the comment section. So this is all about the question number 2 that we're gonna solve. If it is clear to all of you, then we will move it to question number 3. As we can see in the question number 3, we need to give some example. One example. It's for binomial of degree 35 and monomial of degree 100. Here you can take it any one, or you can take it any variable like m, n, or as per you want. Okay, it's up to you. Here let us take. First, let us write an example for binomial of degree 35. If it talks about binomials, that means 2 term. 2 term, it may be separated by plus or minus. So that is up to you, whatever sign that you want to take. So let us take here 6x plus 5. Okay, and let us put the power of 35. That means 6x power 35 plus 5. Here the term is 2. Here it is 1 term. Here it is 2 term. That means 2 term is there. If it is 2 term, then we call it as binomial. And what is the power that we have? That is 35. So this is an example of binomial with degree 35. Let us write this example. Example of binomial with degree 35 is, we can write this one 6x power 35 plus 5. Okay, and now let us write example for monomial with degree 100. If it talks about monomial, that means it is only one term. And we can take any one, like 4x or 4m, anyone as per you want. Okay, here what is the power that we have, that is 100. It should be 4x power 100. Okay, so it's up to you. If you want to take this x, another variable, you can take it a y, as well as m, as well as z, anyone, that is up to you. So this is all about the question. Has access to solve it or to write it in this question. The question asks us to write an example for each of binomial of degree 35 and monomial of degree 100. We wrote it. So this is the answer for this question. Okay, if it is clear to all of you, then let us proceed to question number 4. As we can see in question number 4, write the degree of each of the following polynomial. Each of the following polynomial, we have to write it, the degree of polynomial in each of this Roman number. First, in first Roman number we have 5x cubed plus 4x squared plus 7x. And Roman number 2 we have 4 minus y squared. And Roman number 3 we have 5t minus root 7. And Roman number 4 we have 3. In each of this we have to write it their power. In order to solve it, let's begin it from Roman number 1. What is the question? The question has asked us to write the degree of each of the following. Okay, if it talks about degree, we have to check it which in this polynomial, which of this, either this one or this one or this one, which one have the highest power. The highest power that we have is 3. Highest power is, how much it is? That is 3. If the highest power is 3, that means degree is 3 in this polynomial. Okay, and even here we can use the same process. Solution 4 minus y squared. Here the highest power that we have is 2. The power that y has is 2. That means highest power will be 2 and degree will be 2. Degree is 2. Okay, and here in Roman number 3 we have 5t minus root 7. 5t minus root 7. If there is no power in this variable, then it means that it is 1 here. Okay, highest power will be here 1. Highest power is 1 and degree should be 1. And let us proceed to Roman number 4. In Roman number 4 we have only this constant term, that is 3. Now actually in order to take the degree of each of this polynomial, we need some variable, but here we have only constant term. That means here highest power should be, there is no variable which has some power, thus it will be, even the highest power will be 0 in this case. Okay, and degree should be, degree is 0. Is it clear to all of you? Okay, then if it is clear to all of you, then I will move it to the last question, that is question number 5. As we can see in question number 5, classify the following as linear, quadratic, and cubic polynomial. Actually, we are given with 7 7 question, that is 7 Roman number of polynomial. Among this, we have to check it which one is linear and which one is quadratic as well as cubic polynomial. In order to proceed it, our question, let us first begin it from Roman number 1. In Roman number 1, we have solution. We have x squared plus x. Here let us check it. What is the degree that we have here? Degree is 2. That means the highest power that we have here is 2. If the highest power is 2, then we call it as quadratic. Okay, quadratic polynomial. And if the highest power is 3, then we'll call it as cubic. Here the highest power that we have is 3. That means it will be cubic polynomial. Okay, and what is this? Here we have y plus y squared plus 4. What is the highest power that we have that is true? If it is true, then we will call it as quadratic. If it is 3, if the highest power is 3, then we will call it as cubic. And if the highest power is 1, then we will call it as linear. Here the highest power that we have is true. Because of that, we will call it this one as quadratic polynomial. Okay, quadratic polynomial. Okay, then by using the same process, even here we'll solve it this one. In Roman number 4 we have, that is 1 plus x. Here we have only x. If only this variable is there, that means here the power is 1. Okay, that means the highest power is 1. If the highest power is 1, then what should we call it? We will call it as linear. Linear polynomial. Okay, and let us proceed to this Roman number 5. What do we have in Roman number 5? We have 3t. If there is no power just for this, that is the t, then we'll just take it as this one as 1. Okay, that means it will be linear polynomial. Then what is this? We have r squared. And what is the highest power that we have? The highest power that we have is 2. If the highest power is 2, we call it as quadratic. Okay, quadratic polynomial. And at last we have 7x cubed in Roman number 7. Here what is the highest power that we have? The highest power is cube. If it is cube, then we will call it as cubic polynomial. Okay, this is all about the problem that we will solve it today. Though you may find difficulties or you may help a doubt in understanding all this problem, if you have such kind of confusions or queries about all this problem, please comment down below, and hopefully we will be uploading any videos within a short span. And if you find helpful in watching my videos, please do like, share and subscribe for more videos to come. Wish you all the best, and that's all for today. Thank you.